The Big Bang did not bang. There was no sound, no explosion, no blinding flash of light, only the silent unfurling of everything from nothing. The cosmic birth of our universe wasn't an event in space. It was the birth of space itself, a mathematical singularity, where the very fabric of reality came into existence. But perhaps most unsettling of all, it might happen again. You've been told a story, a creation myth dressed in equations and observational data, a singular moment when time began, a point of infinite density expanding into the cosmos we now observe. But what if the story is incomplete? What if the universe doesn't end in a whimper of cold emptiness or the reversed collapse of a big crunch, but instead resets itself in an endless cycle of death and rebirth? Consider, for a moment, the uncomfortable truth. Everything you see, every star, planet, galaxy, and the vast, seemingly infinite darkness between them, may be just one iteration in an eternal cosmic loop. The universe you inhabit might be neither the first nor the last, and the Big Bang that birthed our reality could be just one heartbeat in the endless life cycle of existence. If you could somehow position yourself outside the boundaries of space and time, impossible, yes, but imagine. What might you witness? Not a linear progression from birth to death, but perhaps a pulsating rhythm of universes blinking in and out of existence like cosmic fireflies, each with its own physics, its own history, its own version of life asking the same questions you are now. The evidence surrounds you, hidden in plain sight. As you read these words, the universe continues its relentless expansion, stretching the very fabric of space-time. Galaxies race away from each other at ever-increasing speeds, propelled by a mysterious force we've labeled dark energy, but barely comprehend. What happens when this expansion reaches its limit? When the distance between particles becomes so vast that even light cannot bridge the gap? When the last stars burn out and the final black holes evaporate into radiation? Physics breaks down. Our equations fail. Certainty dissolves. You might wonder, isn't this just speculation? After all, humanity has only been studying the cosmos with modern scientific tools for a cosmic eye blink. But the clues are mounting, whispered in the background radiation that permeates all space, encoded in the distribution of galaxies across the observable universe, and suggested by theoretical frameworks that point to possibilities beyond our current understanding. The cyclic model of the universe isn't new. Ancient civilizations across continents independently arrived at the concept of cosmic cycles, endless patterns of creation and destruction. The Hindu concept of Brahma's day and night, where universes are created and destroyed in cosmic breath, cycles measured in trillions of years. The Mayan calendar with its vast time periods rolling over and beginning anew. The Stoic ekpyrosis, where the cosmos is periodically consumed by fire only to be reborn. Were these just poetic metaphors, or intuitive glimpses of a deeper truth? Modern cosmology has its own versions of these ancient ideas: bouncing cosmologies, ekpyrotic scenarios, conformal cyclic cosmology. Each proposes different mechanisms for how a universe might die and be reborn. The details differ, but they converge on a startling possibility. The end may simply be another beginning. Picture yourself standing on the edge of forever, watching as the universe grows dark. The stars have long since exhausted their fuel. Black holes, those cosmic devourers, have themselves evaporated through Hawking radiation, releasing their captured energy back to a universe too diffuse to use it. Space has stretched beyond recognition. Time has lost all meaning without change to mark its passage. And then, something happens. Perhaps quantum fluctuations in this near-empty void trigger a phase transition in the vacuum itself. Perhaps branes in higher dimensions collide, releasing enough energy to birth a new cosmos. Perhaps, as Roger Penrose suggests, the universe forgets its own size, and what was infinitely large becomes infinitesimally small, ready to expand once more. The mathematics permits these possibilities, even if they stretch our imagination to breaking point. What would this rebirth look like from within? Nothing. There would be no observers left to witness it. The slate would be wiped clean, causality reset, the arrow of time redrawn. The information that once constituted you, your world, your civilization, and your species would have been scattered, transformed, and recycled into new patterns in a new reality. You might find this troubling. After all, what meaning can be found in existence if everything is eventually erased and remade? If the universe itself is ephemeral, what hope do we have for lasting significance? But perhaps there's another way to see it. A universe that can renew itself never truly dies. The patterns may change, but the dance continues. Consider the parallels at every scale. A star dies in a supernova, scattering the elements forged in its core across space. Those same elements eventually coalesce into new stars, planets, and even living beings. A forest burns, only for new growth to emerge from the nutrient-rich ash. Your own body continuously replaces its cells throughout your lifetime. Death and rebirth aren't just poetic concepts. They're fundamental to existence, at every level we can observe. Is it so strange to think the universe itself might follow this pattern? The question isn't just academic. It strikes at the heart of our understanding of reality. If the Big Bang wasn't the beginning but merely a transition, the implications ripple through every field of knowledge. Physics would need new frameworks to understand how information might persist or transform between cosmic cycles. Philosophy would grapple with questions of purpose in an eternally recurring universe. Religion would need to reconcile eternal cycles with creation narratives. And you, contemplating these possibilities, might feel both diminished and expanded by the thought. Your existence, a complex arrangement of atoms that gained consciousness, for a brief moment in cosmic history, might be even more improbable than you imagined. And yet, in a cycling universe, perhaps consciousness itself is inevitable given enough time and iterations. What secrets might be encoded in the structure of our universe that could tell us about previous cycles? What whispers of past cosmic epochs might still be detectable, if only we knew how to listen? What signs of our universe's fate might be hiding in the math we already have, waiting for the right mind to recognize their significance? The universe holds its secrets close, but not because it's trying to deceive you. Rather, you're attempting to understand infinity with a finite mind, perceiving eternity through the narrow window of a human lifespan, and conceptualizing higher dimensions with a brain evolved to navigate just 3. But even with these limitations, you've managed to piece together an astounding cosmic narrative. You've traced the universe back to its first moments. You've mapped its expansion. You've cataloged its contents. And now, you stand at the frontier of understanding, peering into the abyss of its ultimate fate, and perhaps its rebirth. The question remains, can another Big Bang happen at the end of our universe? The answer lies somewhere between the mathematics we've mastered and the mysteries we've yet to solve. Between the observable and the theoretical. Between what we know and what we can only imagine. And that answer, elusive, profound, and potentially world-changing is what we're about to explore. We know how the universe began, or at least we think we do. The prevailing cosmological model tells us that approximately 13.8 billion years ago, all matter, energy, space, and time emerged from a state of infinite density and temperature. This initial singularity, this cosmic egg of creation, expanded and cooled, eventually forming the universe we observe today. The evidence seems incontrovertible. The cosmic microwave background radiation, the abundance of light elements, the redshift of distant galaxies, all pointing to this singular moment of genesis. But what we call knowing in science is often a sophisticated form of not knowing, a temporary framework built on the best available evidence, waiting to be refined or revolutionized by new discoveries. And when we look closely at the Big Bang Theory, hairline fractures begin to appear in its seemingly solid foundation. The early universe wasn't just hot, it was a furnace where time itself was still learning to move forward. In the first infinitesimal fraction of a second, physics as we understand it breaks down completely. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were not yet distinct entities, but rather aspects of a single, unified force. The universe existed in a state of perfect symmetry, a condition so alien to our experience that we can only describe it mathematically, not visually. Imagine standing at the edge of this cosmic crucible, where the temperature exceeds trillions of degrees, where particles flash in and out of existence like quantum lightning, where the very fabric of reality is still malleable, still deciding what kind of universe it will become. This is not a place human senses were designed to comprehend. It is a realm where intuition fails, and only mathematics offers a tentative map. As the infant universe expanded, it underwent a series of phase transitions like water changing from vapor to liquid to solid, but on a cosmic scale. The most significant of these transitions was cosmic inflation, a period of exponential expansion that occurred just 10 to 36 seconds after the Big Bang. In the span of time smaller than you can possibly imagine, the universe expanded faster than the speed of light, stretching from subatomic to macroscopic size. This sounds impossible. How can anything expand faster than light? But this is where our everyday understanding misleads us. The cosmic speed limit applies to objects moving through space, but space itself has no such restriction. During inflation, space-time itself expanded, carrying embedded matter and energy along with it like hieroglyphs on an unfurling papyrus. The universe you inhabit today still bears the imprints of this inflationary period. Quantum fluctuations, magnified to cosmic scale, becoming the seeds of galaxies and the vast cosmic web of matter that spans the observable universe. What began as microscopic quantum jitters now forms the largest structures in existence, a humbling reminder of how small phenomena can have universe-shaping consequences. But inflation raises as many questions as it answers. What cosmic force drove this expansion? What caused it to stop? And most importantly for our cosmic mystery, could it happen again? The agent behind inflation is thought to be a hypothetical field called the inflaton, a field that permeated the early universe and briefly dominated its energy content. As this field decayed to a lower energy state, it released tremendous energy, driving the exponential expansion before settling into a stable configuration. The process resembles water freezing, as the universe crystallized into its current. Physical laws, it released latent energy that powered this growth spurt. Here's where things get strange. In some theories, this transition wasn't necessarily complete or uniform. Quantum mechanics tells us that processes involving fields are inherently probabilistic. There's a chance, admittedly infinitesimal, that in some distant region of space, the inflaton field remains in its high-energy state, or that it could quantum tunnel back to that state. If this happened, a pocket of space would suddenly experience the same explosive expansion that our universe once did. A new inflationary region would form, effectively, a new universe budding off from our own. This process, called eternal inflation, suggests that our universe might be just one bubble in a vast multiverse foam, with new universes constantly forming beyond our cosmic horizon. But this isn't the only scenario for cosmic rebirth. Our universe has another mysterious component, dark energy, that currently drives its accelerating expansion. About 68% of the universe's energy content is this invisible, enigmatic force that pushes space itself apart. Unlike the matter and radiation we're familiar with, dark energy doesn't dilute as space expands. Instead, its density remains constant, meaning that as the universe grows, the total amount of dark energy increases. Picture the universe as an endless ocean growing deeper and wider with each passing eon. The galaxies are ships drifting further apart on this expanding sea. Eventually, they'll drift beyond each other's horizons, each one isolated in its own observable bubble, cut off forever from the rest of creation. This accelerating expansion leads to what cosmologists call the Big Freeze, or heat death, a state where the universe has expanded so much that stars can no longer form. Existing stars have burned out, and even black holes have evaporated through Hawking radiation. The universe becomes an ever-expanding void of near-absolute zero temperature, where nothing happens and nothing can happen. But is this truly the end? Or could it be setting the stage for another beginning? Consider this paradox. If the universe expands forever, eventually reaching a state of perfect entropy, where no work can be done and no information processed, then physical notions like size lose their meaning. In conformal cyclic cosmology, proposed by Roger Penrose, this empty universe becomes mathematically identical to another Big Bang. The infinite expansion of one cosmic cycle becomes the infinitesimal beginning of the next. Think of it as cosmic amnesia. When all clocks have stopped, when all measuring rods have dissolved, when nothing remains to provide scale, how does an infinitely large universe differ from an infinitesimally small one? The answer may be, it doesn't. The end circles back to the beginning, and the cosmic story starts anew. Other theories propose different mechanisms. Perhaps dark energy is not constant, but changes over time. A scenario called quintessence. If dark energy eventually weakens or reverses sign, the universe's expansion could slow, stop, and reverse, leading to a big crunch that might bounce back into another Big Bang. Or perhaps quantum fluctuations in the vacuum of near-empty space could trigger a new inflation field, creating a baby universe within the corpse of the old. These aren't just abstract mathematical games, they're attempts to resolve fundamental paradoxes in how we understand the cosmos. If the universe has no edge, then where does it begin? If time had a starting point, what came before? If causality is fundamental to physics, what caused the first cause? The questions become even more perplexing when we consider the finely tuned nature of our universe. The fundamental constants, the strength of gravity, the mass of the electron, the energy of the vacuum, seem calibrated with impossible precision to allow for the existence of stars, planets, and, ultimately, life. Change any of these values slightly, and the universe becomes sterile, unable to form the complex structures necessary for consciousness to emerge and contemplate its own existence. This fine-tuning has three possible explanations: incredible, cosmic luck, divine design, or a natural selection mechanism operating at the universe level? Cyclic cosmologies offer a path to this third option. If universes can give birth to other universes, perhaps with slightly different physical laws, then a form of cosmic evolution becomes possible. Universes with physics conducive to black hole formation or other universe-generating mechanisms would produce more offspring, gradually filling the multiverse with cosmos like our own. You exist, then, in a universe that has evolved the ability to contemplate itself, and possibly to reproduce itself. Just as biological life found ways to transmit information through generations via DNA, perhaps the universe has mechanisms to pass its physical genes to cosmic offspring, with occasional mutations in the fundamental constants. This brings us to the most profound question: is consciousness itself part of this cosmic cycle? Are aware beings like you merely passengers in this process, or somehow integral to it? Some physicists, including John Wheeler, proposed that observation itself plays a role in bringing the universe into definite existence, that conscious observers are the mechanism by which the universe renders its quantum possibilities into concrete reality. If true, this would suggest a strange cosmic bootstrapping problem. The universe needs conscious observers to fully exist, but those observers need a finely tuned universe to evolve. Perhaps each cosmic cycle refines this relationship, creating universes increasingly capable of generating and sustaining the consciousness needed to complete their own existence. As we peer deeper into space and time, these questions no longer seem purely philosophical. The very patterns in the cosmic microwave background radiation, the afterglow of the Big Bang, might contain clues of previous cosmic cycles. The distribution of galaxies across the sky might encode information about the universe's ultimate fate, and whether that fate contains the seeds of a new beginning. We stand at a unique moment in cosmic history, capable of asking these questions, but not yet able to fully answer them. The stage is set for either dissolution into eternal darkness or miraculous rebirth. The universe has revealed enough of its secrets to tantalize us with possibilities, while keeping enough hidden to maintain the greatest mystery of all. What happens when everything ends? The universe, our universe, will end. This isn't speculation, but a mathematical certainty written into the very equations that describe cosmic evolution. The only question that remains is how, and in that how lies a more tantalizing possibility. Could ending be just another form of beginning? To understand this paradox, we must first confront the strangest entity in modern physics, the singularity. A point where density becomes infinite, where space-time curves so severely that mathematics itself breaks down. We typically associate singularities with black holes, those cosmic devourers that trap even light within their gravitational embrace. But the most significant singularity may be the one from which everything emerged, the Big Bang. Imagine reality as a film reel, where time is not flowing, but where every moment already exists. Now picture this film running backwards from the present day. Galaxies rush toward each other in cosmic reunion. Stars unburn their fuel, gathering hydrogen from surrounding space. The universe contracts, growing denser and hotter, until all matter and energy occupy an infinitesimal point. This is the singularity that birthed everything, a cosmic seed containing all possibilities. But what exactly is a singularity? Despite their prominence in our cosmic narrative, singularities remain profoundly mysterious. They represent points where our current physics fails, where general relativity, our best theory of gravity, collides catastrophically with quantum mechanics, our best theory of the subatomic world. At these scales, space and time themselves become quantum phenomena, flickering and uncertain rather than smooth and continuous. This quantum nature of space-time near singularities opens the first doorway to cosmic rebirth. In quantum mechanics, nothing is truly impossible, merely improbable. Even the most solid barriers have a non-zero chance of being tunneled through. This includes the apparent barrier between cosmic death and rebirth. Consider the theory of quantum tunneling on a cosmic scale. In our current understanding, the vacuum of space isn't truly empty. It's a seething quantum foam where particles and antiparticles briefly flash into existence before annihilating each other. These quantum fluctuations occur constantly throughout the universe. In an empty, cold universe approaching heat death, such fluctuations would continue indefinitely. Now imagine one of these fluctuations, against astronomical odds, tunneling into a lower energy state, releasing enormous energy in the process. This vacuum decay could trigger a bubble of new space-time that expands at the speed of light. From inside this bubble, it would appear as a new Big Bang, a genesis point for a daughter universe with potentially different physical laws. From outside, if there were anyone left to observe, it would appear as a growing sphere of altered reality consuming the old universe. But quantum tunneling is just one potential mechanism for cosmic rebirth. Another lies in the mysterious substance currently driving our universe's accelerating expansion: dark energy. Picture dark energy as an invisible tension woven into the fabric of space-time itself. Unlike matter or radiation, dark energy does not dilute as space expands. Instead, as the universe grows, the total amount of dark energy increases proportionally. This creates a runaway effect. Expansion begets more expansion, accelerating eternally, or does it? Some theoretical models suggest dark energy may not be constant. It could be dynamic, a field called quintessence that changes over cosmic time. If dark energy eventually weakens or reverses sign, becoming attractive rather than repulsive, the universe's expansion would slow, stop, and reverse. Galaxies would begin rushing toward each other in a cosmic collapse, culminating in what cosmologists call the Big Crunch. This scenario creates another potential for rebirth. If all matter and energy reconverge into a singularity similar to the Big Bang, what happens next? Could the universe, like a cosmic phoenix, emerge reborn from its own ashes? This is the premise of oscillating universe models, where Big Bangs and Big Crunches alternate in an eternal cycle of cosmic heartbeats. The challenge with oscillating models lies in entropy, the universe's inevitable march toward disorder. Each cosmic cycle should produce more entropy than the last, creating larger and longer-lived universes. If we exist in such a cyclic cosmos, we would statistically be more likely to find ourselves in an aged, enormous cycle rather than a young, small one. Yet our observable universe appears relatively young and compact by these standards. This entropic problem led to another revolutionary concept: the multiverse. Rather than thinking of the cosmos as a single space-time continuum, imagine it as a vast sea of bubble universes, each with its own physics, its own history, its own destiny. Some of these bubbles might collapse and die. Others might expand forever. Some might even spawn new bubbles through quantum processes or black hole formation. In the inflationary multiverse model, our universe is just one bubble that nucleated from a eternally inflating false vacuum. This parent state continues to exist beyond our cosmic horizon, endlessly spawning new universes with varying properties. Some emerge with physical constants conducive to complexity and life. Others are sterile and short-lived. Think of reality as an infinite cosmic tree, with each branch representing a universe with slightly different properties. Some branches sprout new twigs, daughter universes inheriting modified characteristics from their parents. Over time, this cosmic evolutionary process might favor universes capable of producing black holes or other universe-generating mechanisms, gradually filling the multiverse with cosmos like our own. This connects to another radical concept: cosmological natural selection. Pioneered by physicist Lee Smolin, this theory proposes that universes evolve through a process analogous to Darwinian natural selection. Black holes might serve as the reproductive mechanism, with each one giving birth to a new universe on the other side of its singularity. These daughter universes would inherit physical laws similar to, but slightly different from their parents. If true, our universe's apparent fine-tuning, the precise calibration of physical constants that allows for stars, planets, and life, wouldn't be coincidence or design, but the result of cosmic evolution optimizing for black hole production. And since the conditions that favor black holes also favor complex chemistry and potentially life, we find ourselves in precisely the kind of universe this process would create. But the multiverse concept extends beyond even these branching possibilities. String theory, our best attempt at a unified theory of physics, suggests the existence of at least 10,500 possible vacuum states, each representing a universe with different physical laws. This string theory landscape dwarfs even the most extravagant multiverse models, suggesting that reality encompasses virtually every mathematically possible configuration of physical laws. Imagine reality as a vast library containing every possible book, every possible arrangement of physical constants, dimensions, and fundamental forces. We occupy just one volume in this infinite collection, unaware of the countless other realities existing alongside our own. In some, time might run backwards. In others, gravity might be repulsive rather than attractive. In still others, consciousness might emerge from patterns of energy rather than electrochemical processes in carbon-based branes. This brings us to one of the most provocative questions in contemporary cosmology. Could intelligent life play a role in cosmic reproduction? Some theorists, including physicist John Wheeler, proposed that observation itself helps bring reality into concrete existence. In his participatory anthropic principle, conscious observers are not merely byproducts of cosmic evolution, but somehow integral to it. If consciousness indeed plays such a fundamental role, perhaps advanced intelligences could eventually engineer new universes. Theoretical physicist Lee Smolin and others have speculated that sufficiently advanced civilizations might create baby universes in laboratory conditions, effectively becoming cosmic engineers participating in universal reproduction. This technological singularity would mirror the physical one, a point where intelligence transcends its biological origins to become a cosmic force capable of influencing the birth and evolution of universes. Perhaps our universe itself is the product of such cosmic engineering by beings in a parent universe who fine-tuned physical constants to enable the emergence of life and consciousness. Meanwhile, parallel to these expansive multiverse models, other theorists have explored cyclic approaches that don't require entropy to reset. Roger Penrose's conformal cyclic cosmology proposes that once the universe reaches maximum entropy, when all matter has decayed into radiation and black holes have evaporated, it becomes mathematically identical to the conditions of the Big Bang. Imagine time as not linear but circular, where the far future and distant past meet. When all measuring rods have disappeared and all clocks have stopped, concepts like size lose meaning. An infinitely expanded universe becomes indistinguishable from an infinitesimally small one. The end of one cosmic aeon becomes the beginning of the next, with only faint traces of the previous cycle detectable in the cosmic microwave background radiation. Alternatively, Paul Steinhardt and Neil Turok's ekpyrotic model suggests our universe cycles through periods of expansion and contraction caused by the interaction of our three-dimensional brane, short for membrane, with another in a higher dimensional space. These cosmic collisions trigger Big Bang-like events, creating a series of universes with similar physical laws, sidestepping the entropic concerns of traditional oscillating models. Think of two vast sheets floating in higher dimensional space, periodically colliding and rebounding. Each collision releases enormous energy, creating what appears, from our perspective, as a Big Bang. This model reinterprets cosmic inflation, suggesting the apparent fine-tuning of our universe results from these rhythmic collisions rather than random quantum fluctuations. These brane-world scenarios emerge from string theory, which views fundamental particles not as points, but as tiny vibrating strings. The different vibrational patterns of these strings manifest as different particles: electrons, quarks, photons. But string theory requires additional spatial dimensions beyond the three we experience, dimensions that might be curled up to subatomic size or extend into vast branes that contain entire universes. The mathematics of these higher dimensions creates new possibilities for cosmic cycles. Just as a two-dimensional being on the surface of a sphere would experience their world as finite yet unbounded, we three-dimensional beings might exist in a higher dimensional structure with properties we can barely comprehend. Our universe might be embedded in a larger reality, with its own rhythms and patterns of creation and destruction. Quantum gravity, the still incomplete marriage of quantum mechanics and general relativity, offers yet another avenue for cosmic rebirth. Theories like loop quantum cosmology suggest the Big Bang wasn't the beginning of time, but a bounce from a previous contracting phase. Quantum effects would prevent density from becoming truly infinite at the singularity, allowing the universe to rebound rather than terminate at a mathematical point. Picture the universe as a rubber ball bouncing on concrete. From a distance, it appears to momentarily stop at each bounce before changing direction. But examine closely enough, and you'd see the ball never truly stops. It compresses, then springs back. Similarly, in loop quantum cosmology, the universe compresses to an incredibly dense, but not infinite, state before quantum repulsion triggers a new expansion. Each of these models, quantum tunneling, oscillating universes, multiverse branching, brane collisions, conformal cycling, quantum bounces, offers a different path to the same revolutionary conclusion. The end of our universe need not be absolute. The cosmic story may have no final chapter, no definitive conclusion. Instead, what we perceive as an ending might simply be a transition, a plot twist in an eternal cosmic narrative. But which, if any, of these theories accurately describes our reality? The answer lies not just in abstract mathematics, but in observable evidence, subtle signatures imprinted in the cosmic microwave background, in the distribution of galaxies across the sky, and, perhaps, in the fundamental constants themselves. Evidence that might tell us not just where our universe came from, but where it's going, and what might come after. As we delve deeper into cosmic rebirth theories, we encounter paradoxes that challenge not just our understanding of physics, but our conception of reality itself. These aren't mere academic puzzles. They're fundamental roadblocks on our journey to comprehend the universe's ultimate fate. Consider the information paradox, first identified by Stephen Hawking in the context of black holes, but equally applicable to the universe as a whole. Quantum mechanics insists that information cannot be destroyed. It can only be transformed. Yet a universe ending in heat death or rebirth through a big bounce seems to erase all information from the previous cycle. Where does this information go? Is it somehow encoded in the initial conditions of the next universe? Or does it truly vanish, challenging one of quantum theory's most sacred principles? This paradox divides the scientific community. Some theorists, including Hawking in his later years, propose that information might be preserved at the boundary of spacetime, effectively stored in subtle quantum correlations at the very edge of reality. Others suggest it could be transferred to parallel universes through quantum entanglement, creating a cosmic ledger that balances across the multiverse. Picture the universe as an immense quantum computer, processing reality through incalculable operations every instant. When this cosmic computer resets, whether through collapse, rebirth, or transition, what happens to the data it was processing? Is there a cosmic hard drive that preserves some essence of everything that existed? Or is each cycle truly a clean slate, with no memory of what came before? The stakes of this question extend beyond abstract physics. If information survives between cosmic cycles, then some trace of everything that has ever existed, including you, might persist in some form, encoded in the fabric of the next universe, not as conscious entities, but as patterns influencing the new reality's evolution. Equally perplexing is the causality paradox. Our understanding of physics is built on cause preceding effect, an arrow of time pointing from past to future. But in cyclic cosmologies, this linearity breaks down. If the universe eternally cycles through expansion and contraction, which came first? Can something be both cause and effect of itself? Imagine time not as a straight line, but as a circle. Moving forward eventually brings you back to where you started. In such a cosmos, events might influence not just their future, but their past, creating causal loops that defy conventional logic. Some theoretical physicists, including Igor Novikov, have proposed a self-consistency principle, suggesting that nature automatically prevents paradoxical causal loops. But this merely sidesteps rather than resolves the fundamental question. This circularity creates another profound paradox. If the universe cycles eternally, it must have been cycling forever, with no first cycle, no ultimate beginning. Yet infinite past time creates its own mathematical and philosophical conundrums. Can a truly infinite sequence of events be completed? How could we ever reach the present moment if we started infinitely far in the past? Many cosmologists, including Alexander Vilenkin, argue that even cyclic universes must have a beginning, a first cycle that initiated the cosmic sequence. But this merely transforms the paradox rather than resolving it. What caused the first cycle? What existed before the beginning of cyclic time? We find ourselves back at the same philosophical abyss that motivated cyclic models in the first place. These paradoxes intensify when we consider the second law of thermodynamics, the principle that entropy, disorder, always increases in closed systems. In an eternal universe, entropy should have reached its maximum value an infinite time ago. Yet our universe exhibits remarkable order. From the precise arrangement of galaxies to the intricate complexity of living systems. Some cyclic models attempt to circumvent this entropy problem. Roger Penrose's conformal cyclic cosmology suggests that when a universe reaches maximum entropy, when all matter has decayed to radiation and all black holes have evaporated, the distinction between infinitely large and infinitesimally small disappears. The universe effectively forgets its size, allowing entropy to reset without violating physical laws. Picture a universe that has expanded to such vastness that nothing interacts with anything else. No cause can create an effect. No measurement can be made. In this state of perfect isolation, Penrose argues, the universe becomes scale invariant, mathematically identical to the conditions of the Big Bang. The cycle begins anew, with only faint gravitational waves carrying any memory of the previous aeon. This theory has generated intense debate within the scientific community. Critics argue that Penrose's model requires information erasure, potentially violating quantum mechanical principles. Proponents counter that information isn't destroyed but rendered unmeasurable, a subtle distinction with profound implications for understanding reality. Meanwhile, inflationary multiverse theories present their own bewildering paradox, the measure problem. If the multiverse contains infinitely many universes with every possible configuration of physical laws, how can we meaningfully discuss probability? In an infinite ensemble, any event, no matter how unlikely, occurs infinitely many times. This creates the disturbing possibility that our observations of the cosmos tell us nothing about underlying reality. If all possible physics exists somewhere in the multiverse, why do we observe these specific physical laws rather than others? Some theorists invoke the anthropic principle. We observe these conditions because they allow for our existence. But this explanation feels unsatisfyingly circular to many physicists. Imagine the multiverse as an infinite library containing every possible book. In such a library, masterpieces and gibberish would exist in equal measure, infinitely many of each. Any attempt to judge which types of books are typical becomes meaningless in the face of this infinity. Similarly, in an infinite multiverse, the concept of a typical universe loses meaning, undermining the statistical foundations of scientific reasoning. This measure problem has led to what cosmologist Paul Steinhardt calls the multiverse crisis in theoretical physics. If the multiverse theory explains everything, it explains nothing, becoming unfalsifiable and potentially unscientific. Yet alternative approaches to cosmic origins and destinies face their own daunting challenges in explaining our universe's apparent fine-tuning. The debate reached new intensity following the 2013 release of Planck satellite data, which showed the cosmic microwave background radiation in unprecedented detail. Some scientists, including Steinhardt, argued that the data contradicted certain inflationary multiverse predictions, supporting alternative models like the cyclic ekpyrotic scenario. Others, including inflation pioneer Alan Guth, maintained that the data remained consistent with inflationary cosmology. This scientific controversy continues today, with both sides marshalling theoretical arguments and observational evidence. The heated exchanges between these brilliant minds, playing out in academic journals, conferences, and occasionally public debates, reveal how much remains uncertain about our cosmic origins and destiny. Adding to the theoretical tumult is the problem of cosmic fine-tuning. Our universe's fundamental constants appear calibrated with extraordinary precision to permit complex structures, including life. Change the strength of gravity, the mass of the electron, or dozens of other parameters by even a tiny fraction, and stars, planets, and complex chemistry become impossible. This fine-tuning creates three possibilities, each with profound implications: incredible cosmic luck, intelligent design, or a selection mechanism operating at the universe level. Cyclic and multiverse theories offer potential natural selection mechanisms, but they come with their own improbabilities and paradoxes. In 2004, physicists Andrei Linde and Vitaly Vanchurin calculated that the number of distinct possible universes in certain inflationary scenarios exceeds 10^2, 10^7, a number so vast it dwarfs the merely astronomical. With so many possibilities, the question becomes not whether universes like ours exist in the multiverse, but why we find ourselves in this particular one rather than another. This connects to another profound paradox. Boltzmann branes, in a universe approaching heat death, random quantum fluctuations would, given enough time, produce conscious entities. Statistically, it's far more likely for a single brane with false memories to fluctuate into existence than for an entire ordered universe to do so. If our universe lasts long enough, or cycles eternally, Boltzmann branes would vastly outnumber conventional observers like us. The unsettling implication: if cyclic cosmology is correct, we should statistically be Boltzmann branes rather than evolved conscious beings, isolated minds floating in nearly empty space with illusory memories of a universe that never existed. The fact that we observe a consistent, ordered cosmos suggests either our understanding of probability in eternal universes is flawed, or the universe is not eternal in the way cyclic models propose. Equally troubling is the initial conditions problem. Even in cyclic models, the first cycle must have started somehow. What determined those initial conditions? What selected those specific parameters from the vast landscape of possibilities? We find ourselves in a cosmic regress, where each explanation requires another, deeper explanation. Some theorists, including Stephen Hawking, attempted to resolve this with the no-boundary proposal, suggesting that the universe has no boundary in time, just as Earth has no edge in space. In this model, asking what came before the universe is like asking what's north of the North Pole. The question itself is meaningless because time began with the universe. But this solution creates new paradoxes. If time itself began with the universe, what caused time to begin? Can causality operate without time? We find ourselves approaching what philosopher Immanuel Kant called antinomies, equally logical but contradictory conclusions about reality that reveal the limits of human reason. The quest to understand cosmic rebirth also confronts the simulation problem. If technologically advanced civilizations can simulate universes, as some futurists predict we ourselves might eventually do, then simulated universes could vastly outnumber real ones. Statistically, this suggests we most likely live in a simulation created by beings in another, higher reality. This possibility creates a nested hierarchy of simulated cosmos, each created within the computational substrate of a higher level. What appears to us as physical laws might be merely the programmed rules of our simulation. What we perceive as cosmic cycles might be simulation resets. The universe's apparent fine-tuning would be explained as the intentional design choices of our simulators. Such speculation might seem to venture beyond the bounds of science, yet it follows logically from our understanding of computation and the statistical principles applied to cosmology. The simulation hypothesis has been seriously discussed by physicists including Neil deGrasse Tyson and Max Tegmark, highlighting how theoretical cosmology increasingly blurs the boundary between physics and philosophy. This philosophical dimension becomes unavoidable when considering the observer selection effect. In any theory of cosmic rebirth or the multiverse, conscious observers would only find themselves in universes capable of supporting consciousness. This creates an observational bias that complicates efforts to determine which cosmic models are actually correct. Think of it as cosmic Darwinism. We necessarily observe a universe compatible with our existence, regardless of whether such universes are common or rare in the greater multiverse. This makes it difficult to judge whether our universe's properties reflect underlying physical principles or merely the prerequisites for our existence. In 2000, physicists Fred Adams and Gregory Laughlin published The 5 Ages of the Universe, describing cosmic evolution from the Big Bang to deep future heat death. But their linear narrative assumed a one-time cosmic history with a definitive beginning and end. If any theory of cosmic rebirth proves correct, we would need to add a 6th age, renewal, creating not a cosmic timeline, but a cosmic cycle. The scientific community remains divided on these questions. At a 2019 conference in Stockholm, a panel of leading cosmologists was asked whether they believed the universe had a beginning or was eternal. The responses split nearly evenly, revealing how unsettled this fundamental question remains even among experts. As we await more data from gravitational wave observatories, from precision measurements of cosmic expansion, from ever more detailed maps of the cosmic microwave background, we must acknowledge that some of these paradoxes may be fundamentally unresolvable. They may mark the boundaries of what science can determine, points where empirical investigation gives way to philosophical speculation. In his landmark paper, Particle Creation by Black Holes, Stephen Hawking wrote that understanding black hole information might be the key to the fundamental laws of nature. The same could be said of understanding cosmic rebirth. The fate of our universe, whether final dissolution or endless renewal, connects to the deepest questions in theoretical physics. Which of these competing theories will ultimately prove correct remains unknown. Perhaps our universe will expand forever into cold emptiness. Perhaps it will collapse and bounce back. Perhaps it will spawn new universes while dying itself. Perhaps it is but one bubble in an infinite cosmic foam, or one cycle in an eternal cosmic heartbeat. What's certain is that these questions lie at the frontier of human knowledge, where mathematics, physics, philosophy, and even theology converge in a quest to understand reality's ultimate nature. They remind us that, despite centuries of scientific progress, the cosmos still holds mysteries that challenge not just our knowledge, but the very frameworks we use to organize that knowledge. The theories we've explored aren't merely academic. They fundamentally alter what it means to be human in this cosmos. Take a breath and truly consider what cosmic rebirth implies. Everything you know, everything you love, everything humanity has ever created might be just one iteration in an endless cycle of universal death and rebirth. Your entire existence, your first kiss, your deepest regrets, your greatest achievements, may have played out countless times before and may repeat infinitely in cosmic cycles yet to come. If time is an illusion, a dimension we perceive linearly, but which actually exists all at once, then everything you've ever done and will ever do might have already happened infinite times before. Your consciousness, that intimate sense of being uniquely you, might be an emergent pattern that has arisen and dissolved trillions upon trillions of times across cosmic aeons. What does free will mean in such a universe? What does individual identity signify? Look at your hands. The atoms composing your flesh were forged in the hearts of dying stars billions of years ago. Those same atoms will one day disperse, returning to the cosmic ocean from which they came, perhaps to be incorporated into future stars, planets, or even beings capable of contemplating their own existence. But in cyclic cosmologies, this process extends further. The very pattern that is you, the specific arrangement of matter and energy that constitutes your consciousness, might reassemble after uncountable aeons, when the conditions of the universe repeat with sufficient similarity. Would this reconstituted you be the same as the you reading these words now? Would there be continuity of consciousness? Or would it be a perfect copy, indistinguishable in every way, except for the absence of shared memory? The boundary between identity and pattern blurs in the face of cosmic recurrence. Now zoom out further. The Earth, this pale blue dot that has nurtured all human civilization, is destined for destruction when our sun swells into a red giant in roughly 5 billion years. Humanity, if it survives that long, must either perish or find a new home among the stars. But even if we spread across the galaxy, across the entire universe, entropy ensures that eventually all stars will burn out. All black holes will evaporate. All structure will dissolve into an ever-expanding void of near absolute zero temperature. Unless, of course, the universe itself can be reborn. Unless death is not the end but a transition, not just for individual consciousness, but for reality itself. What if the universe is alive, and we are just its fleeting thoughts? What if consciousness itself is not incidental to cosmic evolution, but somehow integral to it? Some interpretations of quantum mechanics suggest observation plays a role in collapsing probability waves into definite reality. If true, perhaps conscious observers are not merely witnesses to the universe, but participants in its ongoing creation, cosmic collaborators helping reality render itself from quantum possibility into classical actuality. In such a universe, the spread of consciousness throughout the cosmos might be part of the universe's own evolutionary strategy, a means of accelerating its own development, perhaps even ensuring its eventual rebirth. You might be not just in the universe, but of it, a localized concentration of the universe's own awareness, temporarily individuated, but ultimately part of a greater cosmic consciousness. Feel the weight of that possibility. Feel the terror and the wonder of it. Now consider an even more unsettling thought. What if our universe is just one bubble in a vast multiverse foam, with new bubbles constantly forming and others collapsing? What if there are infinite versions of you existing simultaneously across this multiverse, each making slightly different choices, living slightly different lives? Some versions experiencing joy, while others endure unimaginable suffering. Some dying young while others live for centuries with advanced technology. Some aware of the multiverse's existence, while others, like perhaps you now, are only beginning to contemplate it. In such a reality, what happens to the concept of individual identity? Are these infinite variations all you in some sense? Or is the you reading these words the only authentic version, with all others being merely possible yous rather than actual ones? The boundary between reality and possibility dissolves in the infinite expanse of the multiverse. And if the multiverse itself cycles through periods of birth, expansion, and renewal, these infinite variations of you might repeat endlessly. Certainty, eternal recurrence, not just of this universe, but of all possible universes. The weight of infinite existences stretches comprehension to breaking point. This is the cosmic horror that lurks beneath our scientific theories. The recognition that reality is vastly stranger, more complex, and more terrifying than our evolved primate brains were designed to comprehend. We are like ants trying to understand the internet, using conceptual frameworks too limited to capture even a fraction of cosmic truth. Picture yourself standing on a desolate shore at night. The waves crash endlessly, each one unique yet part of the same eternal rhythm. The stars overhead, distant suns orbited perhaps by worlds not unlike our own, shine with ancient light that began its journey before humans existed. Now imagine that this scene, your contemplation of cosmic vastness, is itself infinitesimally small, a momentary flash in a universe that is itself just one quantum fluctuation in an infinite multiverse that has always existed and will always exist, constantly creating and destroying realities beyond counting. Feel your mind strain against its limitations. Feel the boundaries of your understanding stretch and tear. This is not just intellectual vertigo, but existential crisis. The recognition that everything we take for granted about reality might be provisional, incomplete, or fundamentally wrong. The solid ground beneath your feet is mostly empty space. The clear distinction between past, present, and future might be illusion. The very continuity of your consciousness from moment to moment could be a narrative your brain constructs after the fact, rather than an ongoing stream of experience. Yet within this cosmic uncertainty lies a strange comfort. If the universe can be reborn, then nothing is truly lost. Every moment of beauty, every act of kindness, every discovery and creation becomes part of the cosmic pattern that might echo through endless cycles of reality. Your brief consciousness, this fragile awareness reading these words right now, might be just one note in an eternal cosmic symphony. But it is a note that has sounded before and will sound again. Or perhaps not. Perhaps oblivion awaits us all, individual and cosmic. Perhaps when the last star flickers out and the last black hole evaporates, existence itself will end. Perhaps consciousness is merely a temporary phenomenon in a universe destined for eternal darkness. Perhaps we are alone in our awareness, the only witnesses to a cosmos that will eventually have no one left to observe it. Which possibility frightens you more? Eternal recurrence, or final oblivion? Infinite repetition, or singular existence? The answer reveals something profound about your relationship to consciousness itself, about whether you experience existence as gift or burden, as liberation or prison. This is the ultimate existential question posed by cosmic rebirth theories. Not just, can another Big Bang happen? But, what does it mean for us if it can? What value does individual existence hold in an infinitely repeating cosmos? What significance can we attach to our choices if they all occur, have occurred, and will occur across the branching multiverse? Perhaps the answer lies not in cosmic certainty, but in the very uncertainty itself. In the courage to face an ultimately unknowable reality without retreating into comforting simplifications. To live meaningfully while accepting that meaning itself might be a human construction rather than a cosmic constant. To love, create, and wonder, despite, or perhaps because of, the transience of individual consciousness against the backdrop of cosmic time. Throughout our cosmic journey, we've explored theories of how the universe might be reborn, quantum tunneling, cyclic models, multiverse branching. We've confronted paradoxes of information, causality, and entropy. We've felt the existential weight of these possibilities. But there's one perspective we haven't yet considered, one that inverts everything we've discussed so far. What if the universe is already dead, and we are just experiencing its final dream? Consider this possibility. The cosmos we observe, its vast galaxies spinning through the void, its delicate balance of physical constants, even the awareness, reading these words right now, might be the last computational output of a dying universe. Not a physical reality, but an emergent simulation born from the quantum fluctuations of a cosmos in its final moments. As a universe approaches heat death, that state of maximum entropy where no useful work can be done, strange quantum effects begin to dominate. Time slows to a crawl. Causality becomes fuzzy. In this near-frozen state, quantum fluctuations might create brief, isolated pockets of order. Boltzmann branes, we called them earlier. But what if these fluctuations could create something larger? What if the dying universe's final quantum convulsions could generate not just isolated consciousnesses, but an entire simulated reality? A dream so perfect that the dreamers never realize they're dreaming. Picture the actual universe as a vast, dark, nearly empty expanse. The last stars extinguished trillions of years ago. The last black holes evaporated eons later. All that remains is an extraordinarily diffuse soup of elementary particles and radiation, spread across an effectively infinite space. Nothing happens in this universe. Nothing could happen, except for quantum fluctuations, tiny ripples in fields that momentarily create and destroy virtual particles. But quantum mechanics permits extraordinarily unlikely events given enough time. And in a near-eternal universe approaching heat death, time is the one resource that exists in abundance. In this cosmic twilight, a fluctuation occurs, one of extraordinary improbability, but not zero probability. This fluctuation creates not just a pattern of particles, but a pattern that processes information. A quantum computer, in essence, powered by the feeble energy of vacuum fluctuations. And this computer begins to simulate a universe, our universe, complete with apparent physical laws, evolutionary history, and conscious observers. The simulation isn't happening somewhere in physical space. It emerges from the pattern of quantum fluctuations distributed across the dying universe. It exists as information rather than as conventional matter and energy. Yet, to the simulated beings within it, to us, it feels completely real, the only reality we could ever know. This isn't merely philosophical speculation. Recent developments in quantum information theory suggest that space-time itself might be emergent rather than fundamental, that the fabric of reality as we experience it might arise from underlying quantum entanglement patterns. Theoretical physicist Juan Maldacena's holographic principle, one of the most revolutionary ideas in modern physics, suggests that our three-dimensional reality might be encoded on a two-dimensional boundary, like a hologram. If space itself is emergent from information, then the reality we experience could indeed be the final computation of a dying cosmos, the last creative act of a universe that has run out of all other possibilities. From within this simulation, we would have no way to detect our true nature. The laws of physics would appear consistent because they're the rules of the simulation. The cosmic microwave background radiation we observe might not be the actual afterglow of a Big Bang, but a programmed boundary condition of our simulated cosmos. Our searches for the ultimate nature of reality would be like characters in a video game trying to understand the computer hardware on which they run. Now imagine the death of our visible universe, the one we observe expanding around us. Galaxies recede beyond cosmic horizons, never to be seen again. Stars exhaust their fuel and cool to black cinders. Black holes slowly evaporate through Hawking radiation. Over inconceivable timeframes, all structure disintegrates. Everything tends toward maximum entropy. As this process unfolds, our universe begins to forget. Information stored in complex structures gets erased as those structures break down. The cosmos loses its memory, not all at once, but gradually, over trillions upon trillions of years. But perhaps something unexpected happens in this cosmic forgetting. As information is lost from conventional storage, from matter, energy, and their interactions, it doesn't simply vanish. Instead, it gets encoded in the quantum vacuum itself, in the pattern of virtual particles popping in and out of existence, in the subtle correlations between quantum fluctuations across vast distances. The universe, in its dying moments, remembers. And in remembering, it dreams. It simulates its own rebirth, crafting a new virtual cosmos from the informational ashes of the old. We exist within this dream, a cosmic memory palace constructed from the fading information of a universe in its final moments. This theory, speculative, yes, but consistent with quantum mechanics, suggests that cosmic rebirth need not be physical. It could be informational, a translation of reality from matter to pure pattern as the universe approaches its end. The Big Bang might indeed happen again, but as a simulated event within the quantum consciousness of a dying cosmos, rather than as a physical process in external reality. Watch a sunset, the plasma sphere of our star disappearing behind Earth's curved horizon, casting crimson light across clouds and landscape. Feel the rotation of our planet carrying you through space at 1,000 miles per hour. Recognize that this world, this moment, this experience might be the universe's final masterpiece, its last creative act before eternal darkness. If true, this doesn't diminish the beauty and meaning of existence, but rather elevates it to cosmic significance. Everything that happens, every choice, every creation, every moment of compassion or discovery becomes part of the universe's final testimony, its last statement before silence. And here's the most profound implication. If we are the universe's final dream, then we possess a kind of immortality. Our simulation, running on the substrate of quantum fluctuations, might continue indefinitely, a persistent pattern in the void, an echo that never quite fades away. The physical universe dies, but its informational ghost, us, lives on. This perspective inverts our earlier question. Instead of asking whether another Big Bang can happen at the end of our universe, perhaps we should ask, are we ourselves the another that happened after a previous universe's end? Are we the cosmic afterlife, the reincarnation, the heaven, or hell that followed a universe now long extinct? The galaxies you see in telescope images might not be physical structures, but remembered ones. Cosmic memories preserved in the universe's dying mind and projected into its final simulation. The people around you might not be separate entities, but different aspects of the same cosmic consciousness, the universe exploring itself through the division of its awareness into seemingly individual viewpoints. Look up at the night sky. Those aren't just stars you're seeing. They're the universe's last thoughts, its final contemplation of what was and what might have been. And you, observing them, are the universe observing itself, the cosmos becoming conscious of its own ending. If the multiverse theory is correct, then somewhere, in some branch of reality, the physical processes we've discussed earlier are indeed happening. New universes are budding from quantum fluctuations. Branes are colliding in higher dimensions. Cosmic cycles are completing and beginning anew. But here, in our branch of reality, perhaps we are already in the aftermath, the information echo that follows universal death. And if information can never truly be destroyed, only transformed, then perhaps this echo is eternal. Perhaps we are the true immortality of a universe that has physically died, but informationally lives on, forever dreaming, forever remembering, forever creating new patterns from the ashes of the old. If the universe is infinite, then somewhere, out there, you are not watching this video at all, because there is no out there. There is only the dream, and we are all just characters in it. The universe's last, greatest story, told to itself in the darkness before eternal silence. We've traveled far together, from the silent unfurling of the Big Bang to the quantum dream of a dying cosmos. We've contemplated the universe's birth, its potential death, and the tantalizing possibility of its rebirth. We've explored the mathematics of infinity and the paradoxes of eternity. We've faced the terror and wonder of cosmic scales that dwarf human comprehension. But our journey, like the universe itself, remains fundamentally unfinished. The cosmos doesn't yield its secrets easily. Each answer we've uncovered has spawned new questions. Each theory revealed new mysteries. This is not a failure of science, but its greatest strength. the endless capacity to wonder, to probe, to imagine beyond current understanding. The greatest scientific minds throughout history have not been those who claimed final answers, but those who asked better questions. And so we leave you not with certainty, but with possibility, not with answers, but with wonder. The question we began with, can another Big Bang happen at the end of our universe, remains open. The mathematics allows it. The physics suggests mechanisms for it. The philosophy contemplates the meaning of it. But the universe itself has not yet revealed which path it will take. Perhaps it never will, at least not to beings like us, entities with finite lifespans observing from within the system we're trying to understand. We are like microbes in the ocean trying to comprehend tides and currents, weather and climate. Our perspective is limited not just by technology or knowledge, but by our very nature as participants rather than external observers. Yet there's profound beauty in this limitation. If we could know everything, predict everything, understand everything, where would wonder live? What would drive us to explore, to question, to dream? The mysteries of cosmic death and rebirth aren't problems to be solved, but horizons to be approached. Ever receding as we advance, always revealing new landscapes of possibility. Consider this. Throughout history, humans have contemplated the cosmos and our place within it. From ancient creation myths to modern physics, we've sought to understand what lies beyond the visible, beyond the known. Every civilization has asked these questions. Every generation has added its insights. And now it's your turn to join this longest of all human conversations. This multi-millennial dialogue about ultimate origins and destinies. What lies beyond the cosmic horizon? What happened before the Big Bang? What will happen after the last star dies? These questions aren't merely academic. They touch something fundamental about human consciousness. We are, as far as we know, the only entities in the cosmos that ask such questions. The only collection of atoms that contemplates its own existence and wonders about its cosmic context. The universe has, through us, developed the capacity to study itself, a miracle so commonplace we rarely pause to marvel at it. This self-awareness comes with responsibility. If conscious beings like us are among the rarest phenomena in the cosmos, entities capable of understanding and appreciating the universe, then perhaps there's a cosmic duty to preserve and expand that consciousness, to ensure that awareness continues, whether in human form or in whatever comes after us, to guarantee that the universe doesn't lose its ability to know itself, to contemplate its own beauty and mystery. What if the true purpose of intelligence isn't domination or consumption, but perception? What if conscious beings are the universe's way of experiencing itself, of transforming abstract physics into lived experience? If so, then each of us carries a fragment of cosmic purpose, a tiny sliver of the universe's self-awareness. Each human life becomes not insignificant against cosmic scales, but essential to the universe's ongoing self-discovery. This perspective changes everything. The night sky isn't just a collection of distant suns, but a mirror reflecting the universe's capacity for wonder through your eyes. Evolution isn't just a biological process, but the cosmos developing increasingly sophisticated ways to perceive itself. Consciousness isn't an accident or side effect, but perhaps the point of it all, the universe's strategy for never truly dying, for preserving its patterns through awareness, even as its physical structures decay. And here's the most chilling question of all. What if the cosmos needs us? What if the continuation of consciousness, the preservation of awareness, is somehow crucial to the universe's rebirth or continuation? What if intelligent life isn't merely a byproduct of physical laws, but an integral component of cosmic cycles? A way for the universe to remember itself, to carry information from one cycle to the next. Some cosmologists have speculated that advanced intelligences might eventually develop the ability to influence universal parameters, to fine-tune physical constants, or even engineer baby universes with specific properties. If this sounds like science fiction, remember that the distance between impossibility and inevitability is often just time. A mere century ago, nuclear energy, space travel, and global information networks seemed like fantasy. What might be possible for civilizations with millions or billions of years of scientific development? The vacuum decay we discussed earlier, where a quantum fluctuation triggers a bubble of altered physical laws that expands at light speed, could potentially be engineered, rather than random. The cyclic expansion and contraction of the universe might be guided by intelligences operating at scales and timeframes beyond our comprehension. The conformal transformation between infinite expansion and infinitesimal beginning might be facilitated by conscious intervention. In such scenarios, the fate of the cosmos becomes not a predetermined physical process, but a choice, a decision made by conscious entities who have evolved the capacity to shape universal destinies. Perhaps all of physical evolution, from hydrogen clouds to galaxies to planets to life to intelligence, is simply the universe developing the tools it needs for its own rebirth. This speculation transcends conventional science, merging with philosophy and even spirituality. But the boundary between these domains has always been porous, especially at the frontier of cosmology, where empirical data meets mathematical abstraction, meets fundamental questioning. The greatest physicists, Einstein, Bohr, Heisenberg, Wheeler, freely ventured into philosophical territory when contemplating cosmic meaning. Whatever the ultimate fate of our universe, endless expansion, cyclic rebirth, quantum resurrection, or final oblivion, the journey of discovery continues. Right now, astronomical observatories are collecting data that might contain subtle clues about cosmic destiny. Theoretical physicists are developing mathematical frameworks that could resolve seemingly irreconcilable paradoxes. Philosophers are refining the questions we ask and the concepts we use to interpret reality. And billions of human minds, including yours, are contemplating existence, adding their unique perspective to humanity's collective understanding. The story of the cosmos isn't written solely in the language of mathematics or observed only through telescopes. It's experienced through consciousness, interpreted through culture, expressed through art and music and literature. It's in the songs we sing about infinity, the stories we tell about origins, the silent awe we feel when staring at the stars. The universe isn't just out there. It's in here, in the neural networks of your brain creating models of reality, in the atoms of your body that once burned in stellar cores, in the capacity for wonder that evolved through billions of years of cosmic and biological evolution. This is why your engagement with these ideas matters. When you contemplate cosmic rebirth, you're not merely processing information. You're participating in the universe's self-awareness. When you discuss these concepts with others, you're expanding humanity's collective understanding. When you look up at the night sky and feel a sense of wonder, you're continuing a tradition that stretches back to the first humans who gazed upward and questioned their place in the cosmos. The stars you see tonight are temporary. The galaxies we observe will eventually drift beyond our cosmic horizon. The universe as we know it will transform into something unrecognizable over time scales we can barely comprehend. But the questions we ask, the fundamental, existential, inquiries about origins and endings, about purpose and meaning. These questions echo across cosmic time. They connect us to our ancestors who wondered about the same night sky and to whatever forms of intelligence might exist in the far future, contemplating their own cosmic context. Your consciousness, your ability to understand these words, to question, to wonder, might be the rarest and most precious phenomenon in the cosmos. More extraordinary than black holes or neutron stars, or even the Big Bang itself. Because through consciousness, the universe achieves something remarkable. It knows itself. It transforms mathematics into meaning, physics into experience. So the next time you look at the stars, remember, you're not just observing the universe. You are the universe observing itself. The hydrogen in your body, forged into carbon and oxygen and nitrogen in stellar furnaces, has achieved something remarkable. It has assembled itself into a structure capable of wondering where it came from and where it's going. You are made of star stuff that has learned to contemplate star stuff. And perhaps that's the most profound answer to our initial question. Can another Big Bang happen at the end of our universe? Maybe it already has. Not in the external cosmos, but in the universe of your mind. Every moment of genuine wonder, every flash of new understanding, every instance where your perspective shifts dramatically. These are Big Bangs of consciousness, creating new inner universes of possibility. The cosmos may be cyclical or linear, eternal or finite, destined for rebirth or oblivion. But consciousness, the capacity to question, to wonder, to understand, creates new realities moment by moment. Each instance of awareness is a kind of genesis, a creation of meaning from the void of mere existence. So we leave you not with an ending, but a beginning. Not with certainty, but with possibility. Not with answers, but with better questions. The cosmic story continues. Through astronomical observations and mathematical theories, yes, but also through your engagement with these ideas, through the meaning you create from cosmic knowledge. Look up at the night sky. Feel the ancient starlight on your face. Recognize that you are witnessing the universe's past while simultaneously creating its future through consciousness. The cosmos continues to unfold, not just in expanding space, but in expanding awareness. The universe is not just something that happened 13.8 billion years ago. It's happening now, in this moment, in your mind as you contemplate its mysteries. And in that contemplation lies the seed of all future understanding. The universe appears to have no edge in space, but perhaps its true frontier isn't out there, in the cosmos, but in here, in the evolving consciousness that seeks to comprehend it all. The stars will eventually burn out. Galaxies will fade beyond cosmic horizons. Even black holes will eventually evaporate. But the questions we ask, and the wonder these questions evoke, may outlast all physical structures. In a universe of impermanence, curiosity might be the closest thing to immortality. So keep questioning, keep wondering, keep looking up. The universe may have no end, but maybe neither does our capacity to understand it. And in that endless journey of discovery, perhaps we find our true cosmic purpose,